What is redox reaction? What is redox? In I, for no reduction and what? Oxidation. But Oboleabur define redox. Define redox. Redox is reduction and oxidation. You just like you're telling me define redox. Redox is defined as redox. Full stop. I don't know now. I'm going to write down. A type of chemical reaction. A type of chemical reaction. A type of chemical reaction. A type of chemical reaction in which oxidation and reduction. A type of chemical reaction. A type of chemical reaction in which oxidation and reduction. Oxidation and reduction occur together. Occur together. Occur together in the same chemical reaction. Occur together in the same chemical reaction. Occur together in the same chemical reaction is called a redox reaction. Is called a what? Redox what? Reaction. It's called a what? Redox reaction. Full stop. Go to next line, paragraph. All the following are redox. Are redox. All the following is or are. Take it there. All the following is slash are. All the following is slash are redox. Except. Go to the next line. A. H plus OH minus equals to H2O. B. H2 plus O2 equals to H2O. C. Zn plus Cu 2 plus equals to Zn2 plus Cu. D. Zn plus HCl, and then we have ZnCl2 plus H2. E. NaCl plus AgNO3 equals to NaNO3 plus AgCl. Okay. That question is for you. From the following here, they say all the following are redox or are except exception. Yes. The answer is what? C. I say all the following are or are except C. C is wrong. Is it only A? A and O is not only A. A and B, wrong. A and E, correct. A and E, correct. Okay, listen. Let's assign oxidation number to know why A and E is the odd out. And I told you from that definition that a reaction is said to be redox if oxidation occur at the same time with what? Reduction. In the same chemical what? Reaction. They will occur together. And what is oxidation in this term? We're going to be seeing it as oxidation as increase in oxidation number. Reduction as what? Decrease. Now, if you look at this species here, the oxidation number of hydrogen here is what? +1. Do you know why it's +1? He's written on it now. Can't you see? It's on top. Just come here and know it's +1. The oxidation state of these two now is also written here as what? -1. Now, there is a rule of oxidation state that says that whenever hydrogen combines or it compounds, the oxidation states of hydrogen in its combined states or compound is what? +1. So what it means that H here is what? +1. There is another rule that also says that oxidation state of oxygen when it is in combined state or compound is what? Minus what? 2. I'm going to check the reactant. H is in the reactant. H is here in water as product. Is there any change in the state of oxidation of hydrogen from this side to this side? No. It's +1 here. It's +1 here. Are you with me now? Even oxygen here as well. Since it's combined, oxygen here is also what? -2. Can you see it now? Sorry. Yes, -2. H here is what? +1. So the sum of both of them gives you what? -1. So you look at this. Oxygen is -2 and -2. It hasn't changed. And hydrogen again here is +1 and here is +1. So there is no change in their oxidation state. So what it means that in this reaction, oxidation and reduction did not what? Take place. So it is not a redox what? Reaction. Now if the reaction is not redox, what type of chemical reaction is this? What type of chemical reaction is this? What type now? There were different types of chemical reaction. What type of chemical reaction is this? Something had reacted. Something reacted. This is reacting, and this is forming this. This reacted, and this OH. Both of them gives you water. Of course, you should know that the pH of water is what? 7. That means the pH of H plus is less than 7. pH of OH is what? Greater than 7. The pH which is less than 7 is acid. The pH which is greater than 7 is what? Is base. So this is acid-base reaction. So this is what? Neutralization reaction. So what does it mean now that all neutralization reactions are not what? Redox. Every reaction where acid react with base to form salt and water is not a redox what? Reaction. Take notes. So this reaction is not redox, and the type of reaction here in the first option is what? Acid base or what? Neutralization. Let's go to the second one and see if it's redox as well. Who can tell me now? What is the oxidation number of hydrogen here? 0. I think you know why it is 0. There's a rule. I'm still going to state the rule again. Those of you that were here last year, you all should know the rule. Take up to 9 or 8 rules. The same thing for this man because it's not combined with another atom. So its state is also what? 0. Remember the rule that says that combined state of hydrogen is +1. Combined state of oxygen is what? -2. That's why everywhere you see oxygen in its combined state, it will always be what? -2. Anywhere you see hydrogen in any compound, it is what? +1. So that is it. Now, well, look at this. Hydrogen has changed from 0 to +1. Is that oxidation or reduction? Something is 0 now. Now, the product now is +1. Is that oxidation or reduction? So from here to here is what? Oxidation. Now, something is 0 now. The over here is -2. Is that oxidation or reduction? Reduction. So what is this chemical reaction? Is it redox or not redox? It's redox. Is what? Redox. Redox. What is redox? A reaction in which oxidation and reduction occur together in the same word reaction. Are you following now? But my question now is, what type of chemical reaction is B? What type of chemical reaction is B? Any reaction where you see A plus B equals to AB. That is exactly what you see here. H element plus O element equals to H2O molecule or compound. What type of reaction where element combine with element to form compound? What type of chemical reaction is this? What type? What type? It's what? Combination. If I don't want to call it combination, I can still call it what? Addition. If I don't want to call it addition, I can also call it what? On the board. What is this? Synthesis. What? Reaction. How is this synthesis? Do you know what is synthesis? Produce. You produce water from what? Reaction of what? Hydrogen and what? Oxygen. Whenever you combine two elements and then the product is compound, the type of reaction is called what? Combination. Or what? Addition. Or what? Synthesis. So what can you say about synthesis or addition reaction? All addition reactions, all synthesis reactions are what? Redox. Redox now. Any other synthesis reactions are what? Redox. Are you with me? Apart from this one now, any other example I will give to you now, provided it is an addition reaction, it will definitely be what? Redox. We can give another one. You go think. An element like iron, Fe plus S. The two combine to form what? FeS, which is what? Iron 2 sulfide. You can check it. Sulfur and oxygen belongs to the same what? Group. So oxygen forms -2. Sulfur will also form what? -2. There is a rule that says that whenever an atom, two or more atoms in a compound, will always give an oxidation number of what? The sum of oxidation number of atoms of elements in a compound like this is equal to what? 0. So now that sulfur you know is -2, iron you don't know is what? +2. Because the sum must be 0. That's why you peg +2 here. But both of them are already in atomic state, Abi. So both of them are what? 0 and 0. Is it redox or not redox? Is what? Redox. What type of reaction is this? Synthesis, combination, or addition. Then here, you added sulfur to iron. It forms a compound. Addition. You combine iron with sulfur. You form what? Iron 2 sulfide. Combination. You synthesize iron 2 sulfide. By what? Reacting iron and what? Sulfur. So the three names can be used interchangeably. Are you with me? Yes, your question. We're coming to that. Oyibo, where are you going? Come. Where are you going? Okay. Next time, permission, eh? Okay. Yes. Well, let's go. Now, let's check. I think this one is sorted out, Abi. So, any type of reaction, like you see element plus element, please know that is a redox word. I can give you many examples, but I'm still coming. You will see example, you will run. I will bombard you with examples. Let's go. Let's see the second one. Zinc here is what? 0. It's uncombined. But if it's combined, it's no longer going to be 0. Are you aware? But now it is uncombined. So it's what? 0. Copper, is it 0? You know why it can't be 0 here? It's charged. So let's look at the charge it has. That would be definitely its oxidation what? Number, which is what? +2. Zinc, this time is no longer 0. Sure you know, because it has charge here. So it's what? +2. And copper now is what? 0. Is that redox reaction? Yes, it's redox reaction. What type of chemical reaction is this? What type of chemical reaction is this? Is what? Displacement what? Reaction. Displacement reaction. How is it displacement? Zinc, being more electropositive than copper, cannot leave copper with what? To be charged, knowing that it is more electropositive or reactive than copper in the electrochemical what? Series. So in this reaction, copper is displaced by what? Zinc. That is why the charge is now switched to what? Zinc. Why copper now is what? Discharged. So this type of chemical reaction is called what? Replacement or what? Displacement. Now let me tell you, all displacement reactions like this, option C, are what? Redox. All displacement reaction like this are what? Redox. Or even if I give you another example that is not this, provided that one particular element displaces another from its compound, is the redox what? Reaction. Because the compound displaced will be reduced. The compound that is displaced will now be what? Oxidized. So it is a redox reaction. See how is redox. This 0 has changed to +2. There is a change in the state from 0 to +2. And this +2 has changed from +2 to what? 0. Let's go to the next one. Zinc. Another one like just like this. This is what? 0. This is what? +1. Recall now. This is what? -1. Recall. This is what? +2 -1. Recall now. This is what? 0. Is it a redox reaction or not redox reaction? It is a redox reaction. Redox reaction. Take it now. Zinc +2. Hydrogen what? 0. But there is one species in that reaction that has refused to change. Which species has refused to change in that reaction? Chlorine. The species that has refused to change, you can remove it and now make this equation to be ionic. If I remove species that are refused to change, chlorine is removed now. So what we now have is what? H+. Chlorine also removed it. What do you have here? Zn2 plus what? H2. This is an ionic equation of this reaction. Every chemical reaction has an ionic form. Okay? How to deduce ionic equation is by looking at what? Species that are not changing. That this oxidation number has not what? Changed. From there, you cannot deduce ionic form of that particular what? Reaction. So this reaction and this reaction is still the same reaction. Which is what? Displacement. Recall I told you, all displacement reactions are what? Redox. There is no exception. Though. All replacement, you can call it replacements. Or displacement reactions are what? Redox. Are you with me? Now the last option here is what? E. Sodium is in group 1, so it should be what? +1 -1. Silver is in group 1B. So those of you that were here with the periodic table is what? +1. O is what? -2. You can now find N. Later, N will give us what? +5. This is what? +1 -2 +5 +1 -1. Check if anything changed in the reaction. Is there any change in the reaction? Check. Sodium is +1. It did not change. Chlorine is -1. It did not change. Silver is +1. It did not change. N is 5. O is what? -2. So the last reaction is not a redox what? Reaction. But can you tell me the type of reaction here? What type of chemical reaction is the last reaction? Double displacement reaction on the board. Double what? Displacement. I thought I would write double decomposition, Abby. What do you mean by double displacement? Look at it. You have NaCl plus what? Watch it. HNO3. Ionically, this gives me what? Na plus, Abi? Cl what? Minus. And then we have Hg plus NO3 minus. Let's see what the reaction will be. This reaction is a type whereby the two compounds in their aqueous solution react by exchange of what? Ions. So what will happen here? This will be exchanged with this, and this will go with what? With this. So you know indicator as sodium displaces silver. Silver displaces what? Sodium. It still is what? Double. Or which you can still refer to as what? Double decomposition. Are you with me? Double what? Decomposition. Is double decomposition a redox reaction? Is it a redox reaction? No. Is single displacement a redox reaction? Okay, my cable single displacement. Supposing I have something like Zn plus CuSO4. Then zinc displaces copper from ZnSO4 plus what? Cu. What type of chemical reaction is this? Single displacement. Are we? Is it redox reaction or not redox reaction? Redox. So take note. Single displacement are redox, but double displacement are not redox. Or the single redox, or the double can make at the same time. It can never be redox. I'm telling you. All right. Rules governing. Please fast. Rules governing as subheading. Rules governing. Rules governing oxidation states. Rules governing. Rules governing oxidation states of chemical substance. Rules governing oxidation state of chemical substance. Okay, look at what we're going to do now. This is going to be my rules for the species. This is a tabular form. Oxidation states. Then example. Please draw quickly. Let's fill the table. The table will be rules that will guide you to know oxidation number of every chemical substance that are available. Finish. Rule number 1. In my class, you have to develop skill of writing fast. Number 1. Who can tell me the oxidation number of uncombined elements? 0. It is what? 0. Example. When you see this element in uncombined states, or you see this element in uncombined states, or you see this element in uncombined states, or you see zinc in uncombined states, or you see iron in uncombined states, what will be their oxidation number in these states? 0. So more than for this kind of element in these free states, they will always be what? 0. ETC, there are so many of them. That's rule number 1. Rule number 2. Combined fluorine. What will be the oxidation number of combined fluorine? That is, whenever you see fluorine combined together with other elements, like if you see it here, HF, or if you see it here, NaF, or if you see it in Na3, AlF6. Whenever you see fluorine combined, not when it's uncombined, whenever it is combined in any compound, it will be what? -1. Take note. Rule number 2. Rule number 2. Rule number 3. What is the oxidation state of combined oxygen? -2. So whenever you see oxygen combined in the following compound, like you see it in H2O, or you see it in sodium oxide, or you see it in copper 2 oxide, or you see it in copper 1 oxide, copper 2 oxide. What is the oxidation state of this oxygen here? -2. Whenever you see it combined, it is what? -2. Then let's go to the next rule. Combined hydrogen. Whenever you see hydrogen combined, what will be the states? +1. For example, you see it in water, +1, HCl, +1, HF, +1, etc. Number 5. Alkali metal. Alkali metals of group 1, of group 1A, of group 1A in their combined states is what? +1. +1. Example of those metals is what? Lithium plus, sodium plus, potassium plus, rubidium plus, cesium plus, francium plus. Whenever you see them, their compound, they will always be what? +1. Number 5, number 6. Alkaline earths, metals of group 2A in their compound or combined states. Combined states is what? Plus what? 2. Example, beryllium 2 plus, magnesium 2 plus, calcium 2 plus, strontium 2 plus, barium 2 plus. Number 7. Rule number 7. Rule number 7 is on the board. Okay. Number 7. Okay. Charged. Charged. Charged particle. Charged particle. Charged particle. Example, atoms. Atoms or polyatoms. What would be their state of oxidation state? You wouldn't know, but that would be what? Equal to the charge on ion. For example, if I have something like Cl minus, what would be the oxidation state of this? -1. Or if I have OH minus, what would be the charge state? -1. Or if I have MnO4 minus, CO3 2 minus, etc. So this will be the oxidation state of this, -1. For this 2, -1. For this 2, -1. For this 2, -1. Number 8. Number 8. Number 8. Some, yes. equal to charge on ion. Equal to charge. Equal to the charge on ion. Number 8, sorry. This is 7. Number 8 now. Sum of atom of elements. Sum of atom of elements. Sum of atom of elements. That is oxidation states. Close it. That is oxidation states. Oxidation states. Close the bracket. You have to put that in brackets. We'll go to the oxidation states. What will it be? 0. Write 0. Example. That one has to do with compound. Example. H2O. Some of the atoms here is what? 0. Comma. H2CO3. Everything here is what? 0. K2, Cr2, O7. Everything here is what? 0. etc. But in all of these rules, how many rules do we have there? 8 rules. In all of these rules, there are 2 exceptions to the rules. If you rule without knowing there are 2 exceptions, it will not work for you. I'm going to go to the next line. Right. Note. There are 2 exceptions to the rules above. Note. There are 2 exceptions to the rules above. Note. There are 2 exceptions to the rules above. 2 exceptions to the rules above. Number one. In peroxides, look at the spelling of peroxides. In peroxides, comma, oxygen has. In peroxides, comma, oxygen has. In peroxide, comma, oxygen has oxidation states of what? -1. In peroxide, oxygen has oxidation states of -1. That's the exception. Like in that rule, oxidation state of oxygen whenever you combine is what? -2. Except what? Peroxide. Example. How do you write peroxide? H2O2. Give me H2O2. Kedafia. How your pack name here? When I pay bracket there, hydrogen peroxide. Hydrogen peroxide. Hydrogen guinea peroxide. Come again. Example. H2O2. In our example, EG now. In our what we have. Example. H2O2 in bracket. Hydrogen what? Peroxide. Go to the next line. Number 2. Second rule. In metal hydride. In metal hydride. In metal hydride. Comma. Hydrogen has. Hydrogen has oxidation states of what? Look at me. -1. Example. NaH. NaH. Make sure the H is capital. N capital. A small letter. Who can give me the isopack name of that compound? Well, I put a bracket there. Sodium hydride. Sodium hydride. Good. The one are good. Case 1. Go to the next line. Write case 1. Case 1. This case is a question that we must solve. Case 1. Case 1. Calculates the oxidation states. Calculates the oxidation states calculate the oxidation states of sulfur in on the board. On the board. In Fe2 bracket SO4 bracket 3. Yes. Yes. Answer is what? Try and see if you can. Please, whenever you're solving this problem, you must apply all the rules. Some of the rules, not all. Some of the rules will help you to solve and for you to find sulfur. Yes. Answer is what? Is what? Plus 6. Plus 6. Okay, now listen. Let's see. Fe2 bracket SO4 bracket what? 3. You know, you look as if two variables are unknown. First, it is sulfur. Second, it is what? Iron. You see the point? Because the rules here did not ascertain oxidation state of iron. There is no rule here for iron, isn't it? The rule is just 8 in number. So how then do we know the state of iron? It's here looking at you, but you don't know. First of all, think of how this compound were formed. How is it formed? I'll tell you something. Scatter these things. You know what I mean, scatter? Scatter it this way. This is like saying, this is what? Fe3 plus SO4 2 minus. That is scattering. Join it again. Join it again. These 3 go here. These 2 go here. Then you now go back to what? Fe2 bracket SO4 and what? 3. The same rule that states why water molecule formula is H2O. It's the same rule. H and O. This is what? Plus 1 minus 2, or 1 and 2. The first one here that has charge is what? Oxidation what? State. Abi? The second one that does not have charge is what? Is what class? Valence. So what do you do here? This one will go to O. This two will go to what? H. But we wouldn't say that because the formula is H2O, the oxidation state of H is T plus 1. But you are now multiplying by what? 2. Because the atom must combine in a fixed what? Ratio. Are you with me? Atom must combine in a fixed what? Ratio. This is the ratio they water combine with what? Sorry, hydrogen combine with what? Oxygen. Now the same thing is applicable here. That can tell you that at this point that Fe, oxidation state of Fe is not plus 2, but what? Plus 3. Rather, you multiply by number of atoms in the compound, which is what? 2. Multiply by 2 atoms. Then the one you are looking for is what? Sulfur. How many sulfur are in this compound? 3. So this times this is what? 3. So sulfur would be what? 3 what? X. X's. 3x. So oxygen is what? How many there? Oxygen is what? 12. Multiply 12 by oxidation state of okay. Oxygen is minus 2. Multiply by the number of atoms there is what? Is what? 12. Plug these values here. Remember that this is equal to what? 0. I'm going to plug this here. You now have what? Plus 3 times 2. Are you with me now? Then that is iron. This is iron now. You have now changed it to plus 3. The atoms. Plus what? Plus 12 times what? Minus what? 2. Everything is equal to what? Okay, plus 3x. But let's do it according to how the atoms are arranged. So we now start plus what? 3x plus 12 times what? Minus 2 equals to what? 0. Let's evaluate properly. This time this is what? Plus 6 plus 3x. This is what? Minus 24 equals to what? 0. Try collecting like terms here. We have what? 3x equals to 0. This crossover the sign of equality become what? Plus 24 minus 6. 3x is what? This is 24 minus this is what? 18. Divide both sides by what? 3 here, 3 here. So x alone now is what? Plus 6. Take it down. Photocopy. Photostat it. Another one is coming. Yes. Okay. I'll tell you. In the next case, okay, this case is bygone. In the next case, you find out. I'll give you something similar to this. In the next case, just exactly like this. Let me see who can think of this fast. Case 2. Question on the board. It's on the board. I'm not dictating it. Calculate oxidation states of Fe in FeCN6. 3 minus. Now shift together. 3 minus. Full stop. Give its IUPAC name. Calculate the oxidation state of Fe in Fe bracket sin Cn bracket closes 6 big bracket minus 3. Give me the IUPAC name. After finding what ion is. Yes. Is what? Plus 3. Only the very bad. Kafia. Mba, ozugo. Jide. Ekuzi na, iwote go ofu na, hapuzi nkozo. Iji iwote zanab. Ofichenka. Eh? Okay. Okay, now. First, please watch. It does look like the both self are unknown to you. See, Fe, watch me, Cn bracket 6, and then this, minus 3. Everything is equal to what? Minus 3. Agreed? Remember the rule now. Whenever you see a particle, a molecule that is charged, what will be the other state? Equal to the charge on the what? Ion. So the charge on this particular species is minus what? 3. Start with that first. But no one is going to give you mark for doing this. You either the answer is correct or wrong. Okay, let's see. What are we looking for here? Ion. In Ege Monte now. Ion. Watch, it is not magic. Watch so you understand the first one. Whatever thing I will do, you apply to the first one. That is exactly the same principle. We're getting. Whenever you are looking at or calculating problems from redox reaction, the species that stand out is, let's say, have A and B. This A is at the left hand side of the reaction. So it's left, Abby. This is what? Right. The species at the left will always be positive. Species at the left will always be what? Negative. Why? Is it why? Are you asking me why? Why not? So let me come again. Species, this is A, Abby. Left is what? Positive. I think I made a mistake before. Then right, neg. Left, pose, right, neg. Look at what I mean by that. If I always use this as a symbol, H2O, this is what? Left. So anything up again, never have getting plus. Are you with me now? And anything that will be here is what? Minus. No this and no peace. When I get me now, scatter these things, scatter these two atoms here, scatter it. It does look like, who is the owner of 6 there? Who owns 6? Ion. Carbon. Yeah, carbon. That is cyanide. Cyanide. No, please go and check your periodic table now. Cn is what? Cyanide. Not carbon, no. Carbon is only carbon. C now. Give me beef. Cobalt. It's not carbon 2 oxide though. If it is carbon 2 oxide, O will be consistent with C. How now be consistent? How now be capital? You go check here. Who is the owner of the 6? Ion. If ion is the owner of the 6, that means definitely it's going to be what? Plus 6. Can they have plus 6? Never. Tentatively. Okay. 6 plus. Just check something. But okay, just since ion is how many atoms in this compound? How many moles of ion is here? How many moles of ion are you seeing here? Okay, 1. Who is one of that one? Is cyanide. So oxidation state of cyanide is what? -1. Do you understand? No. H2O. In a fear. Who is the owner of these two? Who is the owner of this one that is in oxygen? So hydrogen will now be what here? +1. This one will be what? Where? -2. The same principle that guides this one is also guiding this one. So with this now, because this is definitely minus, you cannot all say at this point that ion is +6 because the whole of this thing is -3. So what are we going to do now? The answer is now is this minus this is the answer. But let me solve it for you. Well, let's go. So for the fact that they asked us to find ion, Fe is what? X. Cn, based on what I just did now, is what? -1. Therefore, sum of Fe bracket. Okay, well, let me now plug these values here. If I see this man, I'll put what? X plus what? 6 times -1 equals to -3. X minus 6 minus 3. X minus 3 plus 6. X is what? Plus what? 3. Oh, I made 16 for 11 now. -3. Answer is what? 3. Kedafia. Each name here now, the one whose oxidation state appears to be unknown, you just find out now to be +3, will be named last. We name what? Last. And then because the oxidation state of ion is unknown, and then after much we were able to find out that X, which is ion, is now positive. Plus what? 3. Please, in this case now, you will always change the IUM that end that species must be changed to what? ATE. But unfortunately, in writing iron, I-R-O-N, nothing like I-U-M ending iron. No, you have to go and Google, search what is the other name for iron in the Google or in the scientific Google. Another name is what? Is what? Ferrium. Is at this point, okay, see here, ferrium happens to have IUM. Remove IUM, replace it with what? ATE. Hence, the name of the compound is what? Hexa. Cyanoferrate 3 ion. Does it follow? Ongwa kande. Isim de akya. Nena fieba. Hexa. Kwe remember hexa. Now cyanide go nekita. 6. That's 6 is hexa. Hexa cyano. Imagine when you can ionate. Before you change ATE, you must be replacing it from where? IUM. So you now have to search for what? For the ion that ends with what? IUM. Unfortunately, it is what? Ferrium. So that is why the name of ion will now be assumed its Latin name as what? Ferrium. But this time it is what? Hexacyano what? Ferrate what? Ferrate. When you come with the 3. Write that 3 in Roman what? Figure. What's the Roman figure of 3? I. In parentheses. You know, you cannot stop here because the compound given is what? Ionic. So the name will end in what? Ion. Anybody with jump pre 50? Pre 50 jump. Please, sir. How do you know ion also number is +2 and +3? Good question. I will tell you now. You know now. Do you understand now? I think I told you you understand by the next example. So if I tell you something you believe, open REDOX for me. Open REDOX for me. Am I board? Uchi content. Or that agree? Hi, no time when you waste the channel in REDOX. Take this one down as example what? Sorry, case what? Case 3, Akwia. Let's get one case from here. The IUPAC nomenclature. The IUPAC nomenclature. The IUPAC nomenclature of the compound. The IUPAC nomenclature of the compound Li of the compound LiAl LiAlH4 is question mark. LiAlH4 is question mark. Manyagi option. All the option now, but manyagi option. Option, but when they met tumbom. I'll catch them. Yes. If you know it, you share with us. in fellowship. Share with me. Share with me now. Yes. Yes. No. LIALH4. Yes. No. Say it again. No. No. Okay. When I give a name where, what is the oxidation state of lithium? +1. Then here. What is the oxidation state of hydrogen? Where's issues? Because you can the rules now. If you that now, this is a metal hydride. Whenever hydrogen combines with an element whose ending is IUM, like now, if you see something like NaH, what will be the oxidation state of hydrogen in this case? Is it +1 or -1? In this case, hydrogen is what? +1. How do I know? This is sodium hydride here. Any combination where hydrogen combines with other atom of elements in a compound, and then the element in that combination appears to have ending IUM. Oh, we didn't last year. How do you identify an element to be a metal? Any element that ends in IUM except what? Helium is a metal. Is this like here now? Is it one like an ion? Is it no ferrium? No IUM. Is it like a copper and copper ER coprium? See, came like a silver argentum. Is it came like a lead? Is it not getting plumbium? You have what and what you call this again? Utaka sama metal. When any group 1 nine lithium, sodium, potassium, rubidium, cesium, francium, metals. You got a group 2, or got like that. Group 3, or got like that. You got group 4, carbon, silicon, germanium, metal, semi-metal. You call it what? Metalloid. Senedium, tin, metal. Lead in that same group, metal. You buy a group called nitrogen or metal or non-metal, non-metal. Can you know phosphorus, metal or non-metal, non-metal. So every time if you see how it combines with element that ends in IUM, like here, this ends with IUM. Oxidation state of hydrogen is not +1, but what? -1. But here is what? +1. Have you seen the difference? Have you seen where it will be +1 and where it is what? -1. Take note so that you don't get to answer 5. Now, this is -1. How many atoms of H is here? So total is what? -4. Can you figure this bar? That if you add it with this 1, minus will be 4. The sum of everything here will be 0. What number will be here for aluminium? +3. The answer is +3. So how do you now name it? The one whose oxidation state was unknown will be mentioned last. So start naming from positivity to negativity. From positivity to negativity. Start with what? Lithium tetrahydrido aluminate. It's not going to be aluminum again. Sure, you know. When will it be aluminium? If it is uncombined. Or when its oxidation number is what? 0. We're getting aluminium. But in the case where it is positive, what name will you attach to it now? 8. Remove the IUM and replace it with what? 8. The answer is what? Lithium tetrahydrido aluminate 3. Does it follow? No, quoi? No, quoi? How? Explain. Explain. Well, let me call the options again. Let me call the options. The options. A. Tetrahydrolithium aluminate 3. Is it correct? B. Lithium aluminum hydride. Is it correct? C. Lithium tetrahydroaluminate 3. Then D. Aluminium tetrahydrolithium. That one does not even make sense. But how can you get there and can't be able to answer? If I were the examiner marking this thing, I tell them option D. I will search for you. I will call you and tell you you're an idiot. You didn't read for people. Because there's no correlation. At least somebody did the option A as your answer. I would have said, okay, tetrahydrido, you trying only that you miss lithium and aluminium. Okay? It should have been lithium first. You didn't start from positivity. The person started from negativity to positivity. You must name from here first before naming from here. So you can't name back again name except the one at the left. If it appears to be the unknown, you now name it. For example, now if I want to name this, the problem will now be that you don't say because this one is at the left up here, you decide to start with this itakokwea. Because here there is no rule from 1 to 8. There is no rule that says carbon is this. The rule states something about what? Oxygen. It didn't say anything about what? Carbon. So it does mean that the one that you are looking for is carbon, isn't it? The one that is unknown will be mentioned last. So how do you name this particular compound now? It then becomes what? Trioxocarbonate. You now see, you don't name it from behind. Trioxocarbonate what? 4. Okay, 4 up here. I think it's 4. You do know how it's 4? You know how it's 4? Minus 2 now. Times 3 minus 6. What will be here? If you add it with minus 6, you have minus 2. What number is that? 4. On Iranian, as them no, equals to minus 2. X plus 3 times minus 2 equals to minus 2. X minus 6 equals to minus 2. X equals to minus 2 plus 6. X equals to what? 4. Hey, I know I'm too far because I know you know it. And now, I did this thing last year. I'm just doing revision. Do you understand? Wait. Throw now. So to say you can work with you. Yes. Yes. You were not here. You were sleeping. Maybe, probably. Apparently, you are sleeping. Exceptions. Now, check your notes. Exception. There are 2 exceptions where it will not be +1. And that exceptions could be whenever it is combined with metals. It is now -1. Check your notes. When non-metals and any other thing that is not metal is +1. But once it is combined with metal, is -1. It's there for you. It's there for you to take. And it will come out in the exam because it's a confusion. It will come out. You will come and take me later that this will come out. And they will know that you know it's +1. So they will give you compound where it will be -1 so that your answer will not tally with the options, with the correct option. You see, they can never ask you a question on hydrogen and they will ask you the one that you know that is +1. No, they may ask you something funny. Go through your past question, you see. They may ask you, find the state of any NABH. They say find boron. They know that you are going to think that hydrogen is what? +1. Solve it, option A will be, I think if you solve it like that, I think your answer will be what? What's the answer? What will be your answer if you solve it like that? It can it be 3? Minus or +3? -3. It's minus now. It's -3 here? That's option A. Then option D will now be +3. Then you see the answer. You write it for the answer. You would just fail with confidence. You know somebody's failing with confidence. So it means that you do not know there is exception. They know you. The exception is a silent point. Examiner knows your weak point. They not go to silent point and bring out what? Questions. They cannot ask you to find the number of one thing where hydrogen you know is +1. No, they will not do that. Or they will ask you a question where it will involve a peroxide, so that you will now think that is -2. Solve with -2, you will fail it. That's why I give you the exception as notes. Anytime you are reading your note and say a teacher say MB, that means the teacher has laid emphasis. Please, no eat and no peace. Please, sir, how do you know iron is +2 or +3? Okay. We're getting to. This is iron, isn't it? And I have O. Share. Oxygen combined, remember the rule, will always be what? -2. The sum of iron and oxygen must be 0. So since you now know that oxygen is -2, iron is what? Iron is what? So what is the name of this thing? Iron 2 oxide. So in this case, oxidation number of iron here is what? +2, not +3. How do I know this? I'm using oxygen to manipulate it. I already know that oxygen is -2. The only way it's not -2 is in peroxide. So it is not a peroxide. So you should know that. Since there is no extra oxygen in it, okay, just take notes. O there is what? -2. Iron there is what? 2 +2. If I have it this way, Fe2O3. O CKBK so alone now. Some of this thing is what? 0. It's a rule. 2x. You know that this one is what? -2. Okay? Times with what? This 3 equals to 0. 2x -6 equals to 0. Okay? 2x is equals to 0 +6. 2x is +6. Shade 2 here, 2 here. Answer is what? 3. Ilonialo. Iloya. Le frequency. You look one kaketa. The frequency. You just see -2 by x equals to 0. You get your answer to be plus what? 2. Or jump on the other side or go as 2. You deal with it. Are you with me? So that's how to know. No one, no. Just that way. Or in like this. There's another method you can also use. You can split it. Know that the owner of this 3 is iron. The owner of this 2 is what? Oxygen. Then from there you fall back to what oxygen is and what iron there is. Any question? Any other question? Now let me clarify something here. Oh, this is fast. I don't fast. You got say when water. Water chi also so. Water chi so, but again it can call here. Let me tell you something. Listen, because I want to, at this juncture now, take you to another level. I think I've solved a lot of problems here. But let me just help you with another problem. One more problem associated with uncle, but Fe2, okay. Uncle, but in F2, where you were told to find S, so, okay. How will I solve first to know? Okay, let me help you. Because so many of you are confused here. The writer will save some of you. Have Fe2 SO4 3. So we were told to find sulfur. So how will we solve first to know iron? Okay, you cannot solve to find iron since sulfur is unknown. Do you get it? You cannot solve to find sulfur since sulfur is what? Unknown. So that is to say that sulfur is not known, but iron is known. But only that you did not see it with your spiritual eye. You did not look beyond it to see it is given. So the one that is not given is sulfur. So there's no way you solve for iron that is already given. In this case, it's given. How is it given? Because this one is unknown. Except, but I think that one will be complex for you to understand. I would have detached this sulfur and solve sulfur alone with SO4. I'll still find the answer. I now know what this man will be. Okay, look at what I'm going to do now. Now, that takes us back to valency. I want you to understand what this valency is and to differentiate it with this thing called what? Oxidation what? State. There are two different things. I'll ask this question, so many of you will fail it. Okay, let me ask a question. What do you understand by the term valency? You know, some of you will start thinking that valency is combining what? Power. No, it is more than that. Another name for valency is combining power. Valency or combining power is the number of electrons in the outermost shell of an atom. That's valency or combining power. Any electron not on the outermost shell of an atom is valency. Or any electron that the atom will use to make a chemical bond is what? Valency. One cannot say that this atom, for example, 1, 2, 3, 4, 5, 6, 7, 8. This atom is what? Count the number of electrons to tell me which atom is that. Which atom is this? With atomic number 8. The valency of oxygen is what? Is 6, Abby. Do you know why it says 6? Because I have defined valency as the number of electrons in the outermost shell. So because of that, if you now say that the valency is what? 6, you are wrong. Because he's not going to use all the 6 for bonding. He can't try it. The one that he used for bonding is valency. Which one is he going to use for bonding now? The unpaired. Which ones are unpaired? This and this. So any electron in the outermost shell used for bonding is what? Valency. So the valency of oxygen is what? Is what? 2. Not what? 6. Is it confusing? How? Okay, well, watch this. And let me step it up to another atom. Which atom has atomic number of 11? Sodium. The valency is what? Do you know why I said one there? That one electron is what is going to use to make bond. During ionic formation, it loses that electron. Abi? Valency is 1. Any electron the atom has used to make bond is what? Valency. No this and no peace. Very simple. You don't always say it is combining what? Power. I don't think so. I think the question is even here. Past question. I've asked that kind of question. I think I even asked that same question. I lift the question from that JAMB. I think it forms part of the questions I gave you your last test. It was there. The last quiz. That same question. Let me check if I can see the question. Not in this topic. I think in chemical bonding. Because bonding also go together with redox. Bondings are also redox. Electrovalent, redox. Covalence is also what? Redox. So let me take you to that particular chapter. Okay, watch that chapter now. I've seen it. Ngwanenia. The question was asked well, watch how far question is. 1990. Some of your parents were not even born then. 1990. Some of your parents that just married far back, married when they were 16 or 17 years or 18 ago, and you are well. Let's calculate it. And you are now 15 years. 15 plus 18. 15 plus 18 is what? Is what? Please help me. 15 plus 18 is what? 33. From 1990 till now, is it not more than 33? It's 34. I know what I'm talking. Okay. Which of the following terms indicates the number of bonds that can be formed by an atom? Which of the following terms indicates the number of bonds that can be formed by an atom? A. Oxidation number. B. Valency. C. Atomic number. D. Electronegativity. Valency. Have you seen what they define now? Well, look at the definition there. We're going to give you a meaning now. Which atom is this? Which atom is this? Nitrogen. Now, the number of bonds this atom can make, how many bonds can it make? 3. That is valency. How many bonds? 1, 2, 3. The valency is what? 3. Not minus 3. Is what? Valency can never be what? Charged. Anybody that says the valency of hydrogen is +1 is wrong. The valency of hydrogen being +1 is oxidation states is +1. Not 1, but +1. If it is what? Oxidation states. What is oxidation states? What is oxidation states? It's the same thing as saying what is oxidation number. It is the number of electrons an atom can lose, share, or gain. Finish. Number of electrons an atom can what? Lose, share, or what? Gain is what? Oxidation state. Let me give you an example with sodium. Sodium. This is sodium atom. How many electrons are there in an atom of sodium? How many electrons are there in an atom of sodium is what? 11. So what it means now that this thing has how many electrons here? 11 what? Electron. How many protons cover? 11 what? Protons. What is the total of the nuclear charge of sodium? Nuclear charge. How do you calculate nuclear charge? Since you say electron is 11, proton is 11. Which of these proton electron, which one is negatively charged? Electron. Which is positively charged? Something having 11 electron and proton is like having 0. Charge is what? 0. That is the rule that says that the oxidation number of a neutral atom is what? 0. Why is it 0? It's because number of proton is equal to what? Electron. Whenever proton equals electron, this nuclear charge is what? 0. Or the neutral. Or just not to lose the electron. Getting outside. Because no way lower oxidation, or a lower ionization energy. Or lose one valence electron. Now, if it loses an electron, how many electrons do you think after loss of electron will remain? How many? It becomes 10e. How many protons still remain there? 11. Because in a proton on the nucleus, it's only during radioactivity that proton could be discharged during decay. But it's not decaying. This is normal chemical reaction. Well, what is the total nuclear charge of this sodium now? Check very well. This is like minus 11 plus 11 is what? Plus 1. They become plus the electron that was lost is going to add it to what? Plus what? E minus. Check what has happened here. This is oxidation. What is oxidation here? Loss of electron. So the number of electrons an atom can lose is what? Oxidation states. Which will be charged. Okay, either not the negative or what? Positive. Does it follow? Does it follow? This one you are not responding. Okay, please. That is the difference. So that sometimes when you do see us write the valency, we do interchange it with oxidation number. Like now, if I want to, listen to me, if I want to write the compound formed between H and O, yes, I can say valency is +1. Valency is what? -2. Sorry, oxidation number. And I told you valency cannot be charged. Good. But take note, this if these two were to be compound, now they want to be compound, the sum of the charges must be 0 in their compound. But as it is +1 minus 2, 0. You must make it 0. How do I make it 0? I will add 2 to hydrogen. So that this 2 times +1 is what? +2. +2 minus 2 is what? 0. This 2 is added here to make sure the charge remains 0 has also affected this man. So that means it will be 2 H pluses against 1 O. So what will be the formula of this compound now formed? It's going to be what? H2 what? O. So that everything to round up to be what? 0. Only exception will be in peroxide. Because you're going to divide this -2 by 2. It gives you what? Minus what? 1 in peroxide. But apart from peroxide, oxygen whenever it's combined is what? Minus what? 2. Please take notes. Take notes. Take notes. Take notes. Finally, case what now? Let's do the last case. Case 4. Calculate the oxidation number. Calculate the oxidation number of Cl in ClO3 minus and give it IUPAC name. Calculate the oxidation number of Cl in ClO3 minus and then give its IUPAC name. Yes. Plus 5. And what is the name? Be audible now if you want to talk. Chloro 5 what? Correct. Trioxochlorate 5 what? Ion. Correct. Is there anybody here that cannot solve it? Is there anybody here that cannot solve it? Since JAMB is going to be multi-choice, you don't even need to solve this. Maybe there's no space to solve. You know that oxygen is -2. You know that there are 3 atoms here. Times in what do you have here? -6. What number will go with -6 to have -1? 5. Simple. ClO3 minus is -1. The one you are looking for is going to be what? X plus 3 atoms of this times -2. Look at the rule that says it here. The rule. Always take note of this. So you don't ask me why is -2 coming from. Where is 3 coming from? Where is -2 coming from? I'm now substituting this O for what? -2. Equate everything as what? -1. So X 3 times is what? -6 equals to -1. X is equals to -1 plus 6. -1 plus 6 is plus 5. Answer. So it's just in name here now. Since chlorine is the one that is unknown, you now have to start from me and name it last, which is what? Trioxochlorate. Chlorine. Chlorate what? V. What? Ion. So how will JAMB ask us such a question? They say, what is the IUPAC name of ClO7 minus? I've twisted the question now. What is the oxidation state of ClO7 minus? ClO7 minus. Question. What is the oxidation state of ClO7 minus? The answer is what? Yes? Sorry, I didn't mean to say this. What is the state of ClO4 minus? Not 7. Tetraoxochlorate what? 7. Ion. Tetraoxochlorate what? 7 what? Ion. What is the oxidation state of ClO? ClO minus. Oxidation state of chlorine in ClO minus. Yes. Yes. Chlorine in ClO minus. Name the compound. It's not -1, no. +1. Name the compound. Correct. Oxochlorate 1 ion. Is that clear? Is that clear? We'll write this thing. Notes. I'm done with problems. Let's go to principles. Notes. Notes. Note that oxidation state of S block elements. Oxidation state of S block elements is fixed. Is on the board. Fixed. Is fixed. Comma. Hence, when naming their compound, their oxidation state is omitted. Their oxidation state is omitted. Their oxidation state is what? Omitted. Their Oxidation state is what? Omitted. Example. CaO. How do you name this calcium and oxygen? Is what? What is the oxidation state of calcium here? +2. But will you say calcium 2 oxide? But why won't you say calcium 2 oxide? Because it has fixed oxidation what? State, which is only +2. Because maybe bracket there is about calcium oxide. Calcium oxide, not calcium what? Calcium 2 what? Oxide. Calcium oxide, not what? Calcium 2 oxide. And why is it so? Why is calcium an S block element? Is it S block element? Is S block, Abby? Do you know why it's S block element? Atomic number, what is the atomic number of calcium? 20. If you write the electronic configuration of calcium, it will end in what? In what? 4s. Or 4 now, because it's in period 4. Should we try it? Should I leave it? I feel like not doing it. I feel like assuming that you know it. And sit down. Equals to 1s2, 2s2, 2p6, 3s2, 3p6, 4s. This 4 means it belongs to what? Period 4. Group what? 2. Why is it an S block element? The last subshell is what? S. Every element whose last subshell is S must have a fixed oxidation number, which will not what? Change. Other multiple. Other variable. One cannot say the same thing that cover this calcium oxide also cover Na2O. How do you name this? Do you say sodium 1 because sodium is 1? Do you say sodium 1 oxide? What do you say? Sodium oxide, because it is also an S block element. By the time you write the electronic structure of sodium, you're going to see that sodium ends at what? At what? 3s what? 1. S block. Are you with me? On the other hand, full stop. Continue writing. On the other hand, oxidation number of P, D, and F block elements. Oxidation number of P. Oxidation number of P, D, and F block elements. P, D, and F block. P, D, and F block elements are variables. Are variable or multiple. Are variable or multiple. Are variable or multiple, comma. Hence, when naming their compound, their oxidation number must be stated. When naming their compound, their oxidation number must be stated. Their oxidation number must be what? Stated. Example. What do you name this as? Is what? Do you say carbon oxide? Why? Because it is what? Multiple or variable. Or because carbon is a P block. How do you know carbon is a P block? Let's check it. 1s2, 2s2, 2p2. Look at why it's P block elements. Are you with me? So when naming it now, please open bracket. The name of this is what? You now write what? Carbon, then 2 oxide. How do you know what? You may be carbon 4. It will the real time with problem. Carbon guinea VI or IV what? Oxide. ETC. That is a common principle. What is the isopack name of these 2 oxide of copper? First one is Cu2O. Second is what? CuO. What is the isopack name of the 2 compounds of copper? The first one is what? Oh, niggas, hey, because Nankabu 2. He is copper 2 oxide, copper 1 oxide. You just feel comfortably. Just feel. This is what? Copper 1 oxide, copper 2 oxide. Minus 2 plus 2 minus 2 plus 1 divided plus 2. Sorry. Plus 1 times 2 plus 2. Plus 2 minus 2 is what? 0. So it's copper 1. Or plus 1. Because not on a 2 copper atom needs 1 atom of oxygen to form this what? Compound in a fixed what? Ratio. But this one needs only 1 to combine with this what? Oxygen. So it's copper 2. The other one is what? Copper 1. So there's no need to say copper oxide since it is not S block. It belongs to what? That copper is the. Okay, so you now see that the two reduction oxidation are two opposite reactions. Sure, you know. This is gain of oxygen, loss of oxygen, loss of hydrogen, gain of hydrogen, loss of electron, gain of electron. But for me, which one is most appropriate for definition of reduction and oxidation? The last one. Loss of electron, gain of what? Electron. So always remember this. You know about this? For definition, this is what I was told when I was in JS3. SS1. You know the chemistry in JS3. What does oil mean? Oxidation is loss of electron, while reduction is what? Gain of electron. It's just like an acronym to remember it. An acronym to remember. So always read with acronym, okay? Or words to remember something. Because you need the exam Kali. So you'll be using acronym. So you don't forget this. Acronym for redox is what? Oil what? Rig. Okay, now let me do this before my time is up. It's very important. Let me prove all these definitions. I'm going back to the rules again. Maybe you don't understand the rule. This is time to understand it now. I want to demonstrate why this is gain of oxygen. This is carbon, isn't it? And I combine it, it gains oxygen. It then turns into what? CO2. What is the oxidation number of carbon? 0. What is the oxidation number of carbon here? You may not know. But you may know it through this man. This man is minus 2. So this man must be what to balance this in 0. What will be this man now? Plus 4 plus 2 plus 4. It was 0. But gaining oxygen, the oxidation number has now changed from 0 to plus 4. This is what? Oxidation. I can define it as what? Also, increase in what? Oxidation Guinea number. Another definition has come in now. Are you with me? So apart from this one, and this one, the fourth definition of oxidation now is what? Increase. Can you see? Carbon has just increased from 0 to what? Plus 4. When it gains what? Oxygen. Are you following? Are you following? Yes? It's not charged. I didn't get you again. Uh-huh. Uh-huh. It's not 0 there. Is it 0 now? Now you know it's 0. Okay. I want you to land. I can now, when you are landing, you see your mistake. Listen, please, listen. Based on the rules given to you now, why is this carbon 0? Because it is uncombined. But the sum of these two is also 0. But combined state of oxygen is what? Minus 2. Times with these 2. What do you get here? Minus 4. Carbon is now plus 4, isn't it? So the sum of the two will be what? 0. But now, That has affected this carbon now. Here, carbon is 0, but here, carbon is what? +4. This is oxidation. It is 0 before it gains oxygen. Now, after gaining oxygen, the oxidation state of carbon has now changed from what to what? From 0 to +4. You are going to see these things in your past papers. It's here. How we get you an exam? In the question below, I'm going to give these numbers. They don't know you know it. They don't put this number. They say C plus O2 equal to CO2. They ask you in the above equation, oxidation number of carbon has changed from what to what? Answer is from what to what? From 0 to +4. Check what can you go so? What is this? Ammonia. I want to dissociate ammonia. N2, that is how it is written. Diatomic gas. Plus what? H2. That means this ammonia have lost hydrogen. Can someone tell me the oxidation number of nitrogen? The oxidation number of nitrogen. What is wrong with you? I hope all is well with you. Okay, now tell me, what is the oxidation number of nitrogen here? Yeah. Oh, what is the oxidation number of hydrogen? What is the oxidation number of hydrogen? Is +1. Times it with the atom, there how many? +3. So nitrogen then is what? -3. I don't need you to be thinking this thing again. I don't need you to do that. This is +1. The rules, the rules are there. If the atom combined with hydrogen is a metal, hydrogen is -1. If it is a non-metal, hydrogen is what? +1. Use hydrogen to know nitrogen. It's simple now. Now that this is 3 plus 3, this is what? -3. And over here is what? 0. Check it. It has changed from -3 to 0. Is this the reduction or oxidation? Oxidation. Can't you see? Is -3 greater than 0? No. It is oxidation, not reduction. From -3 to 0. -3 to 0 is oxidation, not reduction. So I can also define it as what? Increase, because there is an increase. Something was -3. After losing hydrogen, it then goes down to what? 0. Is oxidation. It is also the loss of what? Hydrogen. Let's check the last one, which is what? Na. Let me use sodium. Na. Number of electrons there, how many electrons are here? 11. Proton is what? 11. Total here, 0. Okay? It then loses electron. Na. This is what? 10. This is what? 11. Total +1. +1 plus E. Check it. It is 0 before the loss. After the loss, it is what? +1. Is this in oxidation or reduction? Oxidation. 0 to +1 is what? Oxidation. Oxidation and what? Oxidation. Whenever there is an increase in the number of oxidation state of an element or species, that is oxidation. Whenever there is a decrease in the number, that is what? Reduction. Yes? Then whatever you see here will definitely be direct opposite to what? This one. Are you with me now? It will be opposite to this one. Well, let me start describing. I think I can clean this. Now look at reduction here. Look at this. For reduction, you are not fast. For reduction, we have CuO. What is this? Oh, can you guys know copper oxide? Copper what oxide? Copper 2. It's not copper 1, copper 2 plus H2. And I have H2O plus Cu. Watch this carefully. Copper here is what? Plus what? 2. It then has lost this oxygen to this hydrogen, isn't it? And then it's now what? Neutral copper here. Copper here is what? 0. Well, check the change of states. This is what? +2. This is what? 0. What has happened here? Reduction or oxidation? Reduction. What is reduction now again? Is what? No, now, in terms of another, what you are seeing, the numbers you are seeing, what is reduction? Decrease. Decrease in the number of what? Oxidation. Well, based on the numbers you are seeing, define oxidation. Decrease. Anyone that has define based on oxygen terms, you define. Based on hydrogen terms, you define. Based on electron, you define. Based on number of electrons, you also what? Define. Based on oxidation number, you also what? Define. Based on electronegativity, you have to also define. Based on electropositivity, you also what? We define. Depending on the one you ask. So this one is based on the number of oxidation. Copper here is 2. Copper here is what? 0. And this only happened because copper 2 oxide lost this what? Oxygen. By what? Hydrogen. Another example again is going to be this one, but this time I'm going to change this one back to base. Yeah, I'll say Ne2 plus H2 here, NaH3. This is 0, isn't it? I think. Now that you have added hydrogen to it, nitrogen here is what? -3. Is this still reduction or oxidation? Something was 0. Now it's -3. Is it reduction or oxidation here? Reduction. Gain of hydrogen. So that means if you had not gained hydrogen, it would have been still 0. But having gained hydrogen, it's what? Reduced. Are you with me? Then the last one says gain of what? Electron. Let's see this one. Cl is chlorine, isn't it? Number of electrons is how many here? 18 proton. Total is what? 0. It gains 1 electron. How many electrons do you think it will have now? Sorry, this is a mistake. This is what? 17 and what? 17. It gains 1 electron, it becomes what? 18. Proton is still what? 17. Total is what? -1. See what has happened here. It is 0. But after the gain of electron, what happened? It now become what? -1. Is this reduction or oxidation? Reduction. What is reduction again in terms of electron transfer? Gain or loss? Gain. So it does look like anytime an species gains an electron, that means the number of electrons, once the number of electron is more than that of proton, the species will become negatively what? Charged. But once the proton is more than that of electron, species becomes what? Positively charged. And the only criteria for proton to be more than electron is when an atom gains. When an atom lose electron. Criteria for a species to be positive is when it loses electron. If you lose electron, it will not lose proton. So proton will now be slightly more than what? Electron. But when the species gains electron, number of electron will now exceed proton. Species becomes what? Negatively charged. The reason why chlorine is negatively charged into chloride ion is because it gains the electron. Then the electron number now is now more than that of what? Proton. Or proton minus. I told you last time that what is oxidation state? The number of electron the atom can what? Can gain, lose, or share. 3 things. Okay. So now, that will not take me to something very serious. Which is what? Take it down as subheading. Oxidizing and reducing agents. Subheading. Oxidizing and reducing agents. Oxidizing and reducing agents. Okay. All right. Oxidizing agent. Let's start with oxidizing agents here. Oxidizing agents. Oxidizing agents. Who can tell us what is oxidizing agent? Oxidizing agent, yes? Yes. In 3 words. What? Yes. Good. Well, write it down. Exactly as he said. Right. They are electron acceptors. They are electron acceptors. They are electron acceptors. That is, they gain electron. They gain electron. They gain electron. They gain electron. You shift over tinye S in bracket. That means they gain electron or electrons. They gain electrons from another chemical substance. They gain electron from another chemical substance. They gain electron from another chemical substance. From another chemical substance to become a reduced species. To become a reduced species. To become a reduced species. A reduced species, comma. On the other hand, on the other hand, reducing agents. On the other hand, reducing agents are electron donors. On the other hand, reducing agents are electron donors. Reducing agents are electron donors. Comma, that is, they lose electron. They lose electron to other chemical substance. They lose electron from other chemical substance. They lose electron from other chemical substance. From other chemical substance. And are themselves. And are themselves. And are themselves. And are, just there, and are themselves oxidized. And are themselves, guinea, oxidized. Can I get an example? Yes. Yes. This is NARB plus chlorine. This is with one valence electron. This is how many valence electron? 7. Which one will give electron? Sodium. Why is sodium giving electron? Because why is sodium giving? Because it has low electronegativity value. In case we more electronegativity we attract. So this sodium will transfer or donate electron to this. See which one is donating. Which one donate electron here? Sodium. Now sodium have now lose electron or lost electron. Before they lost, how many electrons go wherever? 11. How many protons here? 11. Do your plus and minus. What is remaining? 0. Before this one gains, how many electrons is here? 17. How many protons? 17. Total is what? Total is what? 0. Now that this one has lost electron, there is no dot again. This dot is an electron. Okay, which has been transferred to this atom. Now let's see how many electrons remaining here. Here is now what? 10 as against 11 proton. What should be here? Plus 1. Na plus. This one that gains will now have how many dots now? 1, 2, 3, 4, 5, 6. Instead of 7, is now what? 8. Let's see. Electron now exceeds 17. It becomes 18. As proton remains at what? 17. Total is what? Minus 1. Let's see who is the loser. The one that lost electron is what? Sodium. Sodium loses electron to chlorine. On doing that, had oxidized. Can you see now? From here to here, it has what? Oxidized. And from here to here, this one has what? Reduced. The one that has oxidized in this reaction is the reducing what? Agent. The one that has oxidized is what? Reducing agent. So in the reaction now, I cannot say reducing agent is what? Sodium. Why oxidizing agent is what? Chlorine. That's a simple way to know. I will solve 1 or 2 problems from the past question, then I'll call it a day. 1 or 2. 1 or 2. My marker is still writing. You want to give me more? Give me more. Give me more. Okay. Or they kiss each other. They have screen. Okay. Now let's see some questions here. If you have pre 50, you turn over to page 43. Okay. Take it down. Take this question down quickly. Okay. Right. Can I clear this? Let's just 1984. If you have pre 50 page 43, number 5. I'll just do that number, I will call it a day. Well, let's see. CL2. Okay, the question first. Write the question, then you see the question. Don't worry. I'll read the question out. Well, write the question of the reaction, then. Now, listen. Well, continue. In the above reaction. Please, fast. My time is up. Time is up. Time is up. In the reaction above. In the reaction above. I said in the reaction above. Ammonia acts as dash. In the reaction above, ammonia acts as dash. Ammonia acts as dash. Option A, a reducing agent. Option A, a reducing agent. Option A, a reducing agent. B, an oxidizing agent. B, an oxidizing agent. C, an acid. C, an acid. D, a catalyst. D, a catalyst. Answer is what? I say ammonia active. So let's only concentrate on ammonia. H both sides did not change. Are you aware? H combined is +1. H combined here is +1. So this nitrogen is what? -3. Remember now? Then this nitrogen here is what? 0. With this, I know my answer. Check. Nitrogen, has he oxidized or reduced? Oxidized, Abi. Now is the oxidized species. Ammonia is acting as what? I will see you next time.